When you stand at the edge of a port and watch a container ship several stories high being loaded, the whole thing looks almost too simple. Quay cranes move one after another. A spreader grabs a metal box, lifts it into the air, and lowers it neatly onto the ship. At first glance, it feels like this should be easy. There is an empty space on the ship. A container arrives, so you put it there. Isn't it just like stacking blocks or stuffing clothes into a closet? But in the real world, the thing ports and shipping companies fear most is exactly that kind of thinking. If there's space, just put it there. Modern container ships are no longer the giant empty boxes most people imagine. Take one of today's largest ultra-large container ships, MSC Irina, for example. Its nominal capacity is 24,346 TU. TU stands for 20-foot equivalent unit, meaning 1 TU equals one standard 20-foot container. The entire ship is nearly 400 meters long and more than 61 meters wide. You can think of it as a massive floating warehouse. Except this warehouse is not sitting on solid ground. It has to cross waves, currents, and oceans, while stopping at more than a dozen ports along the way. Every extra container loaded onto it changes the ship's weight distribution and balance. A 20-foot box, a 40-foot box, a refrigerated container that needs power, and a dangerous goods container full of chemicals may all look like similar metal boxes to most people. Maybe the color or logo is different, but that seems to be about it. So if the ship is that big, why can't containers simply be placed wherever there is room? The real answer is already written long before the ship reaches the port. It is written in a plan called the stowage plan. Before a container ship actually arrives at the berth, the position of most containers has already been decided. The shipping company, terminal planning center, captain, chief officer, freight forwarders, dangerous goods declaration system, and refrigerated container monitoring system have already calculated things several times around this one ship. A stowage plan is like the blueprint for a massive three-dimensional parking garage. Every slot has its own number. Which bay, which row, which tier, what kind of container goes there, which port it is going to, how heavy it is, whether it is normal cargo, refrigerated cargo, or dangerous goods. All of it is marked in advance. Why does it need to be this detailed? Because the ship is not going to just one place. For example, a ship leaving Ningbo, China, might first call at Singapore, then Colombo, then pass through the Suez Canal, and finally stop at Rotterdam, Hamburg, and Antwerp. At every port, part of the cargo has to be unloaded, and a new batch of containers has to be loaded. Now imagine a container that is supposed to be unloaded in Singapore, but it has been placed at the bottom, with several containers bound for Europe stacked on top of it. What happens when the ship reaches Singapore? The terminal cannot simply lift that container out. Workers first have to move all the containers sitting above it, containers that are not supposed to be unloaded at that port, place them on the quay, take out the target container, and then lift the moved containers back onto the ship. In the industry, this is called rehandling or restowing. It sounds like just a few extra crane moves. Nothing serious. But inside the port system, restowing consumes time, equipment, labor, berth space, fuel, and the schedule reliability of the entire service. When an ultra-large container ship stays at the berth for a few extra hours, every ship waiting behind it has to be pushed back. The terminal's operating plan gets disrupted. The ship's next voyage may be forced to make up time, and the result can become a delay across the whole route. So the first iron rule of loading containers is this. You cannot only look at where there is space. You also have to look at when the container needs to come out. Containers that will be unloaded earlier should be placed as much as possible in upper and outer positions, where they are easier to reach. Containers that will be unloaded later can be placed deeper inside or lower down. Every time a container ship is loaded, the work is really preparing the unloading speed of several future ports in advance. Once the unloading order is solved, the problem is still far from over. Let's zoom in on two containers. They have the same destination. They are exactly the same size. One is loaded with machinery parts. The other is filled with light, bulky cargo. Can these two containers simply swap places? The answer is still no, because their weights may be completely different. Many people assume containers are solid iron boxes, strong enough to take almost anything. But in reality, the real load-bearing structure of a container is mainly its four corner posts. When containers are stacked layer by layer, all the weight from above is transferred downward through the corner fittings and corner posts. If a heavy container is placed on top of a light one, the container below can easily deform or even crack. And what is even more dangerous than container deformation is the way the ship behaves at sea. This is why, starting from July 1st, 2016, the International Maritime Organization's SALAS Convention officially required all export containers to provide a verified gross mass, known in the industry as VGM. A container without a verified gross mass, in principle, cannot be loaded onto the ship. The weight of a container decides whether it can be placed on a certain tier, whether it can sit on top of other containers, whether it can go into a particular stack, and it directly affects the ship's center of gravity and hull stress. Once the weight data is wrong, every safety judgment that follows can also be wrong. The neat walls of containers you see in port become, at sea, a huge structure constantly shaken by waves and constantly under stress. Every tier of containers has to withstand vertical weight, but also the pulling forces caused by side-to-side movement. Lashing rods, twist locks, bridge fittings, cell guides, and deck structures all have their own limits. Once those limits are exceeded, the accident can be irreversible. According to a report by the World Shipping Council, an estimated 1,478 containers were lost at sea globally in 2025. Compared with more than 280 million containers transported in a year, the rate is only about 0.0005%, which is very small in probability terms. But a small probability does not mean a small cost. A floating container can become a hidden reef for other vessels. A sunken container can change the ecology of the seabed. And if the container carries dangerous goods, the pollution it causes to the ocean can be impossible to measure. One of the most typical examples was the one Apis accident in 2020. The ship encountered severe weather in the North Pacific and lost about 1,816 containers at once, including dozens of dangerous goods containers. That incident sent a warning through the entire industry. A container is not finished the moment it is placed on the ship. It remains under stress throughout the whole voyage. So the industry follows a basic principle. Heavy containers should generally go lower, and lighter containers should go higher. That sounds like common sense. But the real difficulty is that a ship does not carry just one stack of containers. It carries hundreds, even thousands, of container slots. The total weight of each stack cannot exceed its limit. Each hatch cover has a maximum load it can carry. The whole ship cannot be too heavy on the left side or the right side, too heavy at the bow, or too heavy at the stern. If the port side is much heavier than the starboard side, the ship will keep listing. If the bow and stern weights are not properly distributed, the hull will experience excessive bending moments and shear forces. If the overall center of gravity is too high, the ship will roll more violently in rough seas, and the lashing system may fail at any time. All of this has to be adjusted bit by bit through weight calculations during stowage planning. Besides ordinary dry containers, there are two types of containers on board whose positions have almost no flexibility. One is the refrigerated container. The other is the dangerous goods container. Let's start with refrigerated containers. Containers carrying frozen meat, seafood, fresh fruit, cold chain pharmaceuticals, and similar cargo need continuous power and temperature control after they are loaded onto the ship. Some also need ventilation adjustment. But not every container slot on a ship has a power socket for reefers. So refrigerated containers have to be placed in designated areas with power connections. Even if there are plenty of empty slots elsewhere, a reefer cannot be placed there without electricity. If it is placed in the wrong position, the cargo may spoil, and the loss can be far higher than the freight cost for the entire container. Then there are the more troublesome containers, dangerous goods. A container of paint, a container of lithium batteries, a container of chemical raw materials, or a container of flammable fireworks material cannot be placed next to other containers just because the size happens to fit. The International Maritime Dangerous Goods Code has clear mandatory rules for the packaging, declaration, stowage, and segregation of different dangerous goods. Some cargo cannot be placed near heat sources. Some cannot be close to the crew's living quarters. Some types of cargo can react dangerously if they come into contact with another type, so they must be kept at a safe distance. The location of dangerous goods containers must comply with the ship's own dangerous goods suitability certificate, and also with the regulations of every port along the route. They cannot block emergency access. They cannot be placed next to incompatible cargo. Even whether they are carried on deck or below deck can be strictly regulated. If a dangerous goods container is put in the wrong place, the consequence is not just a few extra crane moves. At the lighter end, the whole ship may be detained for inspection. At the heavier end, it can cause fire, explosion, and threaten the safety of the entire vessel and every crew member on board. By this point, you can probably see that loading a container ship is never a last-minute judgment made by dock workers on site. It is a precise calculation that begins long in advance and requires many parties to work together. When cargo is booked, the freight forwarder reports the cargo information to the shipping company. How big the container is, how heavy it is, where it is going, whether it is dangerous goods, and whether it needs refrigeration. After the terminal receives the pre-stowage information, it first arranges containers in the yard according to the loading order. Once the ship arrives, the quay cranes work strictly according to the loading plan. The chief officer and captain have to keep checking the ship's stability, draft, hull strength, and all safety requirements. Terminal dispatchers also try to arrange the working routes of multiple quay cranes so they do not interfere with one another and can operate at the same time, pushing loading efficiency as high as possible. But the goals of these different parties often conflict with one another. The cargo owner just wants the container to get on the ship smoothly. The terminal wants the ship loaded and gone as quickly as possible so it does not occupy the berth. The shipping company wants the highest possible slot utilization because every extra container means extra revenue. The captain and chief officer care most about navigation safety and would rather refuse a container than take a risk. The port needs to keep berths flowing smoothly so later ships do not pile up outside the harbor. A qualified stowage plan is the best workable answer among all these competing goals. Loading more containers can increase revenue, but it may reduce stability. Placing containers where they are easier to unload can reduce restows, but it may waste space. Putting all heavy containers lower down makes the ship more stable, but it may disrupt the unloading order. Strictly segregating dangerous goods is safest, but it takes up more space. There is no perfect plan. There is only a result balanced between rules, safety, efficiency, and cost. And a stowage plan is never a static drawing that stays unchanged once it is made. It is more like a chessboard that is constantly being updated. Some containers arrive late at the terminal and miss the ship. Some bookings are canceled at the last minute. Some dangerous goods declarations fail and need to be reviewed again. If a port becomes congested, the shipping company may adjust the port rotation. If the weather forecast changes, the route may also have to change. On top of that, the ship is already carrying cargo left over from the previous port. Newly arriving containers can only be fitted into the remaining space. Every time one container is moved, operations at several later ports may have to change with it. Every time a new batch of cargo is accepted, the ship's weight distribution has to be recalculated. Every time one container is placed in a more convenient position, it may take away the safety margin of another container. Starting January 1, 2026, new rules from the International Maritime Organization officially come into force, requiring mandatory reporting of containers lost at sea. Ships will not only have to report the containers they lose themselves. They will also have to report floating containers they observe during navigation. This marks a shift in the industry's focus. It is moving from simply getting containers onto the ship to knowing the condition of containers throughout their time at sea. Future container loading will look more and more like a real-time intelligence system. The weight, cargo type, Temperature, power status, lashing tension, and position shift of each container may all be monitored by more sensors and algorithms in real time. Stowage systems may identify risks earlier. Cameras on deck may detect abnormal movement in container stacks. The larger the ship, the more complex the route, and the more the system pushes for efficiency, the more important the position of every single container becomes. Because a container ship is never just a huge empty box. It is a moving balance system at sea. Every container occupies a position inside that system, and that position affects the operating rhythm of several ports still ahead. This is actually a very counterintuitive conclusion. Containers made global trade highly standardized, but they did not make ship loading simple. They only hid the complexity inside stowage plans, maritime rules, professional software, lashing systems, and every precise crane movement. Modern shipping can safely carry tens of thousands of containers halfway around the world, but it still cannot load them like stacking toy blocks. That's it for this video. If you enjoyed it, feel free to like, subscribe, and leave a question you are curious about in the comments. See you in the next one.